Hello everyone, welcome to my new video on my Mathematics Essentials series. In this video, I will continue proving trigonometric identities. In particular, I will prove identity 12 and 13 from our list of 19 identities in total. Okay, this will put us well past the halfway mark. And these two identities are known as the difference formulae because you are taking the cosine or the sine of the difference of two angles, theta and phi. Okay, so let's write out the identities that we are proving. Okay, so first identity we are proving is the cosine of theta minus phi is equal to the cosine of theta times the cosine of phi plus the sine of theta times the cosine of phi. All right, let's start the proof. Okay, well, in order to prove this, we just apply one of the sum formulae, okay, which is the one that we will apply is trigonometric identity 10. Okay, now if we go back to our list, this is trigonometric identity 10, the cosine of theta plus phi equal to this expression on the right-hand side, this expression here. All right, so let's go ahead and apply that. Now, what trigonometric identity 10 says is really, you can think of it like this, because I don't want you to get confused between, positive phi and negative phi. It really says that the cosine of some angle, let's call it theta, plus some other angle, okay, which could be anything, equals what the identity says it equals. Okay, we could just replace the other angle with negative phi. Okay, so that's just a little aside so that you don't get confused when I do this. So let's take the cosine of theta minus phi. We know that that's equal to the cosine of theta plus some angle, which happens to be negative phi. Okay, subtraction is just adding the negative. Okay, so why do I write it like this? Okay, it's to explicitly point out that we can interpret this as the sum of two angles. And since it can be interpreted as the sum of two angles, we are justified in applying the sum formulae. So let's do that. Okay, this would be equal to, I'll just give you another look at the sum formulae that we are applying, this one here. Okay, cosine of theta, times the cosine of the other angle. Okay, but in this case, the other angle is negative phi. Okay, minus the sine of theta times the sine of the other angle, which in our case is negative phi. Now, how do we proceed? Well, in the previous videos, we proved these trigonometric identities, 1 and 2. Okay, so sine is an odd function and cosine is an even function. So we will apply those identities. Okay, so here we will apply trigonometric identity 2, right, which says that the cosine of some negative angle is just the cosine of that positive angle. And trigonometric identity 1 says that when we take the sine of a negative angle, we can just move that negative sign out the front. I mean sine as in SIGN, not sine as in the trigonometric ratio. Okay, we can take this negative sign, okay, move it out the front of the sine ratio and take the sine of the positive angle instead. Okay, so that's what trigonometric identities 1 and 2 say. So let's apply them. Okay, this would be equal to the cosine of theta. Well, the cosine of negative phi is just the cosine of positive phi. That's trigonometric identity 2. And when we are taking the sine of theta times the sine of negative phi, well, that's the same as taking the sine of positive phi, but putting a negative sign out the front. Okay, so if we put that negative sign out the front, we would have two negative signs, right? A double negative is just a positive. And this is trigonometric identity 12. Okay, that's what it says. All right. So of course, if you were doing a proof like this in an exam, you should annotate your proof with things, like little comments like this, by such and such, so that each line is justified. If you are applying a trigonometric identity, for instance. Okay, so in this case, it would be by trigonometric identity 1 and 2, etc. Okay, let's prove the other difference formulae. So let's prove this one. This one here. Okay, and when we prove trigonometric identity 13, we will make use of 11, okay, the sum formulae, and we will make use of these as well, trigonometric identities 1 and 2. Okay, so it's structurally similar to the proof that we've just done. Okay, so let's write out what we are proving. We are proving that the sine of theta minus phi is equal to the sine of theta times the cosine of phi minus the cosine of theta times the sine of phi. Okay, so I'm getting into one of the previous proofs. I'll just move over here and write out proof. All right, so the sine of theta minus phi is equal to the sine of theta plus negative phi. So if you can write it as the sum of two angles, you are justified in applying the sum formula. So I will annotate the proof this time. So this would be equal to, this is applying the sum formula, okay? This formula here, Trigonometric Identity 11, okay, which says that when you're taking the sum of two angles, the sine of the sum of two angles, that's equal to the sine of the first angle, theta, times the cosine of the second angle, okay? And in this case, the second angle is negative phi, right? Plus the cosine of the first angle times the sine of the second angle, which is negative phi. All right. Now we apply trigonometric identities 1 and 2, namely that sine is an odd function and cosine is an even function. Okay, so this here, cosine of negative phi is just going to be the cosine of positive phi. All right, and this here, the sine of negative phi, well, that's just negative 1 times the sine of positive phi. So we could move the negative sign out the front. Right, that would make this negative, and we'd have minus the cosine of theta times the sine of positive phi. And that's exactly what this trigonometric identity says. Okay, so that completes the proof. Oh, I didn't annotate it. I should annotate it. So here I say by the sum formulae, or I can say formula because it's one of them, right? And here I can say by trigonometric identities 1 and 2, or since sine is odd function and cosine is an even function, is an even function. Okay, so then we can write a little square to say that we've finished the proof. And we can go back up to our list of trigonometric identities and cross off the ones we've proven. Now, in the upcoming videos, when I prove more trigonometric identities, it will turn out that there are, that there's going to be several ways you could prove them by applying different identities. So, there's several ways we could prove trigonometric identities 6 and 7, for instance. Okay, we could apply the identities we've just proven, the difference formula, by taking one of the angles equal to pi over 2. Okay, or we could apply these identities here, and then within the proof apply identities 1 and 2, or we could, apply the sum formula, writing the difference of these angles here in terms of the sum of two angles. That would justify applying the sum formula, and then apply these identities here. So there are many ways we can prove them. Unless a particular proof is quite elegant, I will just choose the quickest, or the slickest proof. So we have proven 11 of the 19 trigonometric identities on this list, which leaves 8 to go. Okay, if you enjoyed this video, feel free to give it a like. Feel free to share it. If you have a question, just post it in the comments. And if you would like a notification when I upload a new video, just subscribe to my channel. Until next time, bye for now.